Guys, this is question number 3. A 10 kilogram mass sits on a rough surface. So it's a rough surface. Coefficient of friction is 0.35. All the forces on the diagram. Okay, so I'm going to have a weight force, which will be 10G. I will have a friction force, which should be perpendicular to the surface, sorry, parallel to the surface. I'm going to call that friction force, and I will have a normal reactive force. So they're my 3 forces. Draw them in a different colour, make sure they're nice and big. So find the size of the normal reactive force. Okay, so what I've got my 10G broken into one force which is perpendicular to the plane. If that's 30, that's 30, which means that's 10G cos of 30, and that's 10G sine of 30, and that's my normal reactive force. So N is going to equal 10G cos of 30 degrees. Make sure your calculator is in degrees, and that's going to give you N equaling 5 root 3G, or 49 root 3, or 84.87 newtons. I'll accept all 3 answers. Find the acceleration of the mass down the surface. Okay, so if it's accelerating down the surface in that direction, then the resultant force in the direction of motion will be any vectors in the direction of motion, which is 10G sine of 30, minus anything in the opposite direction of motion, which will be mu times n. So it's going to be 0.35 times 10G cos of 30, which is what this was. So 10 times A equals 10G times a half minus 0.35 times 5 root 3G. A equals 1.9295 meters per second squared as being the acceleration. Part D then talks about, okay, here is our 10 kilogram 10G, that's going to be N, and that's going to be my mu times N. Now, it needs to be about to move down the surface. It's about to move down the surface. If it's about to move, it hasn't yet started moving. So acceleration is 0, which means resultant force is 0. Therefore, this component of my weight, which is 10G sine of theta, must equal this component of friction, because the resultant force will be 10G sine of theta minus 0.35 10G cos of theta. And if that equals to 0, therefore 10G sine of theta equals 0.35 10G cos of theta. If I move all of this to the other side, I will get 10G sine of theta on 10G cos of theta, which is tan of theta equaling 0.35. Therefore, theta equals the inverse tan of 0.35, which in decimal places gives you an angle of 19.2900 degrees, and in degrees, minutes, seconds, it's 19 degrees, 17 minutes, 24 seconds. Therefore, 19 degrees, 17 minutes will be my answer.